All right, yeah, welcome back again. We want to look at the homogeneity of variance in this section. Last time I was discussing about parametric assumptions, and I mentioned homogeneity of variance as one of them. We have looked at the normality check, which is a normal distribution. So we want to look at homogeneity of variance as well. This is talking about the sample data must come from a population with the same variance. That's what it means. And this assumption assumes that all groups have the same or similar variance. This assumption is group dependent. Homogeneity of variance is group dependent. It means that in your data set, you have categorical a column, and it helps you to check if the groups you have there they are similar in variance. Maybe you have a gender, for example, gender group in your data set. For example, you have male, you have female. That is two groups. Okay, that is two groups. Then if you want to check with one particular continuous variable to see if that groups you are talking about gender, both male and female, they both have the same variance. That is a homogeneity variance assumption. So they must have the same variance for you to pass the test of homogeneity of variance. So to demonstrate this concept, we need to create a data set. Let's create a data set. We'll have used one of the one you have used before, but let's just create a simple data set to explain what I'm talking about. So let's create a data set of 50 adults with 3 groups and their weights, right? So let's set the seed first. Let's say set the seed. We run this test to set the seed. Okay. All right, so 1, 2, 3 for reproducibility. So let's say we want to create 50 observations, n equal to 50, right? We run that line. So let's create age group. Okay, we factor it: young adults, middle adults, and the old adults. Right. So let us just call it like that. And we run this line. All right, for age group. So our n is for each n is 50. All right. So we run that line of code. Then let's just create a mean and SD. When I say mean, means the mean value of each of them, and the standard deviation of each of them. Let's call it a mean. Give mean 50 for young adult, mean 55 for middle adult, and 60 for old adult. That's their weight approximately. So let's run down. Let's just assign our SD to be 10. So let's generate weight now. Let's generate weight. Our n is 50, right? We have our head SDs have been created, so we assign it here. So we're using arrow norm to do that for 3 sets of data. We are looking at 3 sets of groups, so we generate the weight for each of them. So we have done that. So let's now combine together everything together. We call it data. So we pass our age group here and our weight here. So let's just call it. Let's just run it. So we have created our data set now, data frame. Now you can see let's look at the first 6 row. So we have age group, weight, okay, young adult, and their weight. All right. So we have the data set already. So we can look at the distribution of this data set. We can look at the age group, how they are spread. So let's just look at the SD and mean of each of them. So when we run this line, you can see our age group here. We have middle adult, old adult, young adult. We have a count. Each of them is 50-50, and the mean is the mean for middle adult 56, for young adult 50, for old adults 57. That is a mean. Then we have SD. So this is a data set we have created now. So we can also visualize the density plot because when you're talking about interference, before you even do some testing statistically, you must look and understand the structure, what you're talking about, because talking about equal variance, if you plot a density plot, for example, each density plot of the group must have equal variance. That's what it means. So let's demonstrate this now. Let's look at the plot. So we are creating our plot using ggplot now. Okay. Don't forget, I've already loaded tidyverse and ggplot2. So it's still running. That is why you are not seeing it. So let me just load it here so that you can, in case you don't have it on your own, okay, so that mine is already still running. So that's why I didn't bother to load it. Okay, tidyverse, all right, okay, then like ggplot, all right. So you load it too, okay, and run it. So I don't need to do that. That's why I don't bother. So because it's already running, so I don't need to do that anymore. So now I want to run this line of code, this ggplot code. So that's why I did that. So now I can run this line. Okay, I want to see the age group. So we pass our data here, called data. We pass our aesthetic here to be x-axis, will be weight. Okay, our color is age group. I want to fill. Don't color. This color means outline color. Okay, if I remove this particular fill color, it will still work, but it will be only outline in color. All right, which is not necessarily bad, but we can fill it with color also in fill the color. Then we can make alpha means we want to fade it a little bit so that it can be faded, so you can see the one at the back. All right, that's what we are talking about. So we want to see the one at the back, so that's why we do alpha 0.4. So the lesser the number, the fader it becomes. So we can make it 0.4, 0.5. That should be fine. Okay. So if you make it more sharper than that, it will not be able to see the other one at the back. So that is better for now. So let's just run this and see what I'm talking about. Now you can see we have age group here. Okay, so you can see. Then we have our weight, right? We have so here you can see, look at this shape here, all right? This shape shows that it seems to be conforming to normal distribution, right? But you can see each one at the back. So what homogeneity of variance is saying that the difference of each of them must be equal. Now look at it. Now we have 10, 10 here, 10 here, 10 here. So if you look at it from the middle here, okay, you got the middle here, the one beside here equals to the one here, which means that the each of them have equal variance. Between here and here is 10. Between here and here is 10. Here, if you have this, you don't have to be the middle, for example. Between here and here is 10. Between here and here is 10. So the variance must be equal. That's what it means for homogeneity of variance. So they both have equal variance. So you cannot just assume that this is accurate. So we need to do a proper statistical test to confirm what you are talking about. So the first test I want to carry out here is called Levene test for homogeneity of variance. Levene test. So we're going to carry out Levene test here. Before you do that, you have to install a package called car. I've already installed, so I can just run. All right. So now, what do you do with Levene test? You're passing your continuous variable here, your numerical data here, and you're passing your categorical data here, right? The data is called data. So that is all you need. You need both of them. You need this particular data. And the one thing you must understand that this data should be supposed to be a factor data, must be factored. No, this one already been factored here. So why we are creating it? So you can see that it's already been factored here. If I glimpse now, let me glimpse now. Let's say I glimpse my data, for example. You understand that you can see that it show factor here, right? See, which means I've been factored together. Why I was creating it. If you not factor, then you have to create a factor for it, or you just come here and just include here in your here just include factor here. Okay, just a factor open bracket, then close it. That's all. So that to show that this particular variable is a factor variable. In fact, if you not factor this one will not run. This particular one will not run properly. To give error. This particular data set, if not factor, it will not run. So it requires factor to make this run properly. So you must understand that in case your own is not factor, you have to include factor here, open bracket, factor, close it. Here, same thing, close it, right? So that is the same what I did here. You can see a factor here, right? So just understand that, because that challenges, that's one of the challenges that you may face when you are doing your own. All right, so we have confirmed that okay, this particular plot is homogeneous, is variance in homogeneity. So we want to also confirm with a test. So what do? We have run our test. So we want to run this test And you must understand that if the test is significant, if the p-value is less than 0.05, it means the test failed. All right, the test failed. Homogeneity of variance failed. That means there is no homogeneity of variance. That's what it means. But if the p-value we get is more than 0.05, then it passes. All right, that means that there is homogeneity of variance. All right, so that's what it means. So we're going to do that first for this. We run this now. All right, so we got our p-value is 0.7, which is higher than 0.05. So the test passed. So this Levene test of homogeneity of variance, center is equal to median. So the test passed, right? But we cannot conclude yet. Let us do another one. So that should be enough for us to conclude. But we want to do Bartlett test again, just to, they are both for, you can use any one of them to test, but you want to use both of them to test so that you can confirm what you're talking about. They have the same structure. You pass the weight also here. We pass the age group here. Data is data. So that is a Bartlett test for homogeneity of variance. So let's run this line again and see the result. P-value is 0.8 here also. So which means that this also what passed the test. All right. So homogeneity of variance does not fail. So if it's significant, that means it fails. So, but now it's not significant, which means it passed the test. So this is how to test your data for homogeneity of variance before you go further for parametric tests. So in the next section, we will look at another assumptions probably, and we do whatever we can. So thank you so much for listening. I will see us in the next class. Bye for now.